New England Electropolishing operates 12 dedicated lines focused exclusively on stainless steel electropolishing. They handle all grades, including 300 and 400 series, plus heat-treated alloys with precise pre-cleaning, descaling, and pickling. The process delivers consistent, high-volume polishing, while rigorous inspection and careful packaging guarantee top quality. Watching this transformation is proof of expert craftsmanship in metal finishing. The induction bending process shapes an 8-inch Schedule 40 pipe into a perfect 90-degree angle with controlled heating. This video reveals how metal softens and bends smoothly without cracks. It's impressive to see rigid steel transform so precisely and quickly into custom shapes. Inside a busy foundry, raw materials meet precise craftsmanship as pump and valve castings take shape. Ling Tong casting uses two main processes, sand casting and investment casting, to handle parts from as small as 5 kilograms to massive 4,500 kilogram units. These casting methods utilize pattern materials like wood and aluminum, customized to fit production demands. Skilled technicians oversee every stage to maintain consistency. Every mold is crafted with attention to detail, ensuring accuracy in the final product. The sand casting process relies on alkali phenolic resin sand, chosen for its strength and surface quality, ideal for large parts weighing between 100 to 4,500 kilograms. This method involves preparing sand molds that are durable enough to hold molten metal during pouring. The sand mixture is tested regularly to maintain consistent properties. Meanwhile, investment casting uses zircon sand mixed with Ludox, perfect for detailed, smaller components between 5 and 200 kilograms. This process requires making wax patterns that are coated in ceramic before the wax is melted away to create intricate molds. The waxing process is crucial to capturing fine details in the casting. Ling Tong works with a broad range of materials, including ENGJL 100 through 350 and ENGJS 350 through 800 series, WCB, WC6, WC9, as well as stainless steels such as CF3, CF3M, CF8, CF8M, and various duplex grades up to Super Duplex 6A. These alloys meet demanding standards for chemical and mechanical properties required in industries like petrochemical, power generation, and water treatment. Each material batch undergoes chemical composition verification before use. The foundry prepares molds by carefully mixing sand and binders, ensuring optimal mold strength and surface finish. Molten metal is then poured into the molds under controlled conditions to prevent defects. Real-time monitoring ensures that temperature remains within precise limits. Pouring temperature and speed are carefully monitored for consistency. Once cooled, the casting is removed from the mold, shakeout, followed by heat treatment to refine mechanical properties. Heat treatment improves hardness and stress relief. Afterward, machining removes excess material and finishes critical surfaces. Precision machining ensures the parts meet tight dimensional tolerances. Throughout production, detailed inspections follow ASTM and EN standards, backed by Manufacturing Process Specification, MPS, and Inspection and Testing Plan, ITP documents. Non-destructive testing is applied to detect internal flaws. Final quality checks confirm that every component meets rigorous specifications. Watching these raw materials transform into robust, precise pump and valve components is fascinating. Each casting is a testament to the blend of traditional foundry skills and modern engineering controls. The process demands exacting quality and craftsmanship, critical for parts that support essential industrial systems worldwide. This fusion of art and science underpins the reliability expected from these components. steel heats up and moves forward. At CST Laminacao, thick steel slabs start their journey as they are received, reheated, and transformed into thin coils. The process begins with unloading and sequencing slabs, transported by overhead cranes to the reheating furnace. The slabs reach around 1,200 degrees Celsius, the perfect temperature for rolling. Rolling mills then reduce slab thickness from 200 to 250 millimeters down to 20 to 40 millimeters over multiple passes. A vertical edging mill trims the width to precise dimensions. The slabs, now called blanks, are coiled and temperature homogenized in the coil box. After uncoiling, blanks are cut and sent through finishing mills with 6 rolling stands that bring thickness down to 1.2 to 16 millimeters. The strips are then cooled on a laminar bed and inspected by cameras detecting surface defects in real time. Hydraulic coil winders finish the process by coiling the strips, which are strapped, weighed, and transported to the cooling yard. The coils either proceed to finishing lines for cutting and edging, or are prepared for shipment. This tightly controlled process blends heat, force, and precision, producing steel coils vital for modern industries worldwide. Chains start as simple wires, carefully cleaned and positioned. Each wire is cut and bent precisely to form links. Welding joins each link tightly, eliminating any weak spots. Heat treatment hardens the chain, defining its strength and durability. Surface finishes like sandblasting, electrogalvanizing, or eco-friendly lacquers add corrosion resistance and unique texture. Quality checks are thorough. Testing, bending, and breaking with diamond-tipped tools to ensure reliability. Final packaging secures chains for safe delivery worldwide. At PWAG, strength isn't enough. Every link combines precision craftsmanship and trusted technology. Heavy forging takes place in a large workshop with advanced equipment like rectangular furnaces and electrohydraulic hammers. After forging, links go through straightening and load testing. Certified by API and international standards, these links meet strict quality and safety requirements. Metal under pressure can achieve extraordinary things, and here's how. At Singla Forging, the process begins with engineering and tool design, tailored for components like spline shafts, U-joints, and midship tube shafts. Cold and hot forging operations shape steel into structural forms using automated forging hammers. These parts are then routed through broaching and cold forming facilities to refine shapes and dimensions. High-speed machining centers, guided by CAD/CAM systems, allow multi-angle cutting with extreme accuracy. The in-house heat treatment and induction hardening ensure strength where it matters most. Each part undergoes shot blasting for a clean surface before moving to gear hobbing. The quality inspection areas use both conventional and advanced tools to confirm measurements. Eddy current and durability testing come next. No shortcuts allowed. Every piece is tracked, stored under controlled conditions, and tested again before shipment. The detail is impressive. It's hard not to admire how precision, heat, and motion come together to shape high-duty components that power today's vehicles. This machine doesn't just bend metal, it commands it. The 50 TBRE Mandrel pipe bender works with thick-walled pipes, feeding coiled steel through hydraulic clamps and guided mandrels. Under controlled pressure and rotation, the pipe bends smoothly without wrinkling or collapse. The process is fully programmable, ensuring repeatable results at various diameters and angles. These machines are essential in industries like shipbuilding, power plants, and heavy construction. When raw steel meets controlled force, form and function merge in one powerful twist. Massive beams, engineered for strength and built for endurance, come to life in the Shed 16 project at the port of Tauranga. Jensen Steel Fabricators takes on the challenge of fabricating custom welded Steltec beams for this landmark structure. The process starts long before any steel is cut, with detailed CAD drawings mapping every weld, bolt, and connection for the entire 300-meter length and 70-meter span. Once designs are approved, raw steel arrives at the shop. Each batch of steel is inspected for quality and traceability before moving forward. Overhead cranes move heavy sections into precise positions for fabrication. Skilled teams cut, bevel, and prep each flange and web using CNC machines and plasma cutters. Everything must line up perfectly for a flawless weld. Assemblers tack together the steel components to create the I-beam's core structure. Every fit-up is checked to maintain exact geometry. Welders then use multi-pass and submerged arc welding to achieve strong, deep joints, following strict welding procedures for marine-grade steel. Each weld is scrutinized with ultrasonic, magnetic, and visual inspections, guaranteeing that every seam meets exacting standards. These checks are vital, as the beams must withstand the corrosive coastal environment and support immense loads. After inspection, records are logged to ensure full quality documentation for each beam. The entire journey from raw steel to ready for installation beam is a showcase of precision, teamwork, and industrial expertise. Each beam isn't just a product, it's the backbone of a project that will stand for decades. Standing in the workshop, watching a raw steel plate transform into an engineered giant is nothing short of inspiring. A bearing may be small, but its role is massive. At NBC, production begins with raw steel that's forged, turned, and heat-treated to exact hardness. Grinding machines from Izumi and Nova achieve micron-level finishes. With over 1,000 sizes, from 6mm bore to 2,000 mm outer diameter, each bearing is assembled and tested under strict ISO standards. It's impressive how this facility supports locomotives, power plants, and heavy machinery around the globe. Quality control checks align with AAR and ISO 9001 certifications. Their footprint spans India, Japan, Sweden, and Italy, proving consistency knows no borders. When a power plant grinds to a halt, there's no time to waste. Preformed winding specializes in manufacturing high-voltage coils, fast. The journey starts with top-grade copper, tested for purity before it's shaped into loops by automated machinery. Each loop can reach up to 9 meters in mean turn length, an impressive feat. Coils are formed on machines that store memory profiles for future runs, ensuring every set is identical. After shaping, insulation is applied using advanced resin-rich or vacuum pressure impregnation systems, and the coils are pressed for perfect slot fit. The process is rigorous, with every coil undergoing earth testing, tan delta, interturn, and partial discharge checks. Quality isn't just a promise, it's built into every stage. What's really remarkable is their speed. A custom coil set can move from inquiry, design, production, testing, to shipment in just 7 days. Watching these skilled hands and machines work so precisely is genuinely fascinating. Their dedication to quality and turnaround time makes a real difference for industries that simply cannot afford delays. These molds define performance on the racetrack. The process starts with high-grade steel blocks, precisely CNC milled to create detailed tread patterns. Injection molding follows. Molten rubber is forced into the cavity under high pressure and temperature, replicating every groove. Once cooled, the mold opens, revealing a perfectly formed racing tire. It's incredible how much speed and grip are born in these metal shells. Tight tolerances ensure consistency between batches, because even a fraction of a millimeter can mean victory or defeat. It's incredible how much steel goes into building the backbone of the power grid. At Sabre, manufacturing starts with precision-driven design software that feeds directly into CNC cutting programs. Massive steel plates are shaped, cambered, and welded into tubular poles, some supporting up to 750 kilovolts transmission lines. Each piece is inspected multiple times, then galvanized or finished in weathering or painted steel. Watching those long shafts move through climate-controlled coating lines is oddly satisfying. Their two locations together process up to 193 million pounds of steel annually. Every detail, from flange plates to dulling, supports strength, corrosion resistance, and fast delivery. It's industrial efficiency at a seriously impressive scale.